Okay, so we're going to do probability, and we're going to think about combinations versus permutations, okay? So they've given us this question. There are 5 siblings, Paula, Mike, Stephanie, Kurt, and Emily, right? So we have a girl, boy, and a girl. So 3 girls, 2 boys. Probability of 3 girls on one side of a table. That's what they're really talking about here. So we need to decide, are we going to be working with a permutation or a combination? The probability is going to be essentially the total amount of options, right? So how many possibilities are there with our combination? So total possibilities. We'll call it total possible. And on top, it's going to be how many ways can we arrange 3 girls? So not 3 ways, but how many ways? How many ways? Now, the difference between a combination and a permutation is that permutations are where order matters. So in this question, if they had said, of the 3 girls, Paula must be first. Oops. The 3 girls, Paula must be first, Stephanie must be second, and Emily must be third. That is where order would be important. But because they've said the 3 girls, what that essentially gives us is, we could set this up with Paula first, Stephanie, then Emily, or Paula, Emily, Stephanie. Or we can completely mix it up and go Stephanie, Paula, Emily, Stephanie, Emily, Paula, and then finally we can go Emily, Stephanie, Paula, or Emily, Paula, Stephanie, right? So already how many ways we have? We have 1, 2, 3, 4, 5, 6. There are 6 possible ways we can arrange that on top. Okay, and that's where a combination comes into this question. And then we got to go by the total amount of possibilities. Now, we could have actually figured out this how many ways by using a combination to figure out everything, right? So when we go to use our combination, so we'll say the probability of the event happening, we'll call it NA, probability of the said event. All right, just before we go on, we got to specify that in this question, probability of 3 girls on one side of the table, and then we reread it after in the middle. So we're going to just quickly draw a diagram, excuse me, of what this looks like to help us understand that. So in other words, they have a big long table like this, and what they're saying is they want 1, 2, 3 girls, which we know there are 6 ways we can put these 3 girls, right? But they also said with the boys on the outside, essentially the girls all in the middle. Well, the first case would be if we had boy 1 or Mike and Kurt like this. Or we can duplicate this entire thing. If we draw another table, what if Kurt was on the other side and Mike, so in this case Mike's on the left, Kurt's on the right. What if we did it vice versa? Kurt on the left, Mike on the right. How many more options do we have for those girls to be in the middle again?
6.
Okay, so because that changes things, it is not just a possibility of 6, but because there's 2 options, we essentially do 6 plus 6, which gives us 12. So there are 12 possibilities of this event. So again, because the girls are in the middle, that means the order is going to matter in this question. So because the order is mattering, because we reread the question after, as we're looking at a permutation here, because the order matters. So in other words, when we choose our 5 total people, and how many ways can we arrange those 5 people? Is that what we did? 5p5? Yeah. What did you get when you did it?
120.
120. So we get 12 over 120, which is a probability of 1 in 10. There's a 1 in 10 chance that the girls will be placed in the middle. All 3 of them will be in the middle in this question. Okay? So again, that's because in this question we hadn't read it before. Had they just been choosing, what if they were saying, what is the probability that we just choose any 3 girls, okay, out of this group of 5? That would have been a combination. But because they said they choose them to put in specific spots, that makes this a permutation in the question. Okay?